Hey everyone, I'm Jing from Google. So today I will spend some time on some of our latest work, FHIR data model on Kotlin multi-platform. Short intro, I'm a software engineer at Google. I've been working on OpenHealth Stack and Android FHIR SDK in the last few years. You might know some of these projects from me and from our team members who are present at DevDays. There's other talks from our team. The natural language queries on SQL, from SQL to FHIR, from FHIR, and then Divya just gave a talk on the computable guidelines work on Android. And tomorrow there's another talk by FHIR on FHIR proxy or FHIR info gateway. So if you're interested, please go and check out tomorrow. Right, so a little bit of background on the work that we do in general. OpenHealth Stack is a set of tools that help developers build apps on Android and on other platforms, front-end and back-end. So the components include the info gateway or the proxy, as we colloquially call it, or the FHIR analytics, and then the Android FHIR SDK libraries and other components and tools. So we have a dev site where you can find more information, developer resources, our partner stories, etc., etc. So in particular, the most relevant component to this topic today is the Android work that we've been doing. So that's the tool for you to build Android apps using Kotlin. So since we started the Android work, there's been a very strong ask from the community to extend our work to multi-platform, because people want to use things, want to build the app for not just for Android, but also for iOS. They want to build once and deploy to multiple platforms. First of all, I want to say there are existing efforts actually in this area. There is a library in Flutter that you might not know about. It's called Firefly. I think they presented previously at DevDays as well. So if you are a Flutter dev, please go and check it out. It's really cool. But what we are trying to do here really is to work with our existing ecosystem, with our developer communities, and help Android devs, Kotlin devs, and dare I say Java devs to start using some of the multi-platform capabilities to extend their sort of target audience. So a quick word on Kotlin multi-platform. I'm not going to have time to go into details, but it's essentially a new technology, relatively new technology, that allows you to reuse Kotlin code on different platforms, but also allow you to plug in your native code if necessary. Right? So there's a mechanism called expect actual implementation to do that. There's a lot more information. I think it's an emerging technology that's quickly gaining a lot of popularity. So what are the challenges? The biggest challenge we're facing whilst trying to do this on multi-platform is that multi-platform libraries require multi-platform dependencies. So if you're a Java dev or Kotlin dev, you're used to writing Java code or Kotlin code, you can't just move that to multi-platform because you typically have a lot of JVM dependencies. And then when you're trying to write multi-platform code to deploy that on iOS, for example, where there's no JVM, or if you want to deploy in a different environment where JVM is not running, then it's not going to work. So we do need a multi-platform data model from the get-go that has pure multi-platform dependencies. So we have been using the happy FHIR structures in Android FHIR SDK. We chose to use that because it's popular, because it's in Java, and then we could get it to work on Android. But it's not a simple story, because the happy structures library is actually written for server-side Java. So when we did pour that to Android, we actually faced some of the issues which we were able to resolve because we could exclude certain dependencies from the Android build file. But the problem of like the dependency, the Java dependencies that they have in the happy structures library, like Jackson library, like the Apache sort of dependencies on server side, they still exist. And this now has become a blocker for moving to multi-platform. So that's why we did this. That's why we built this Kotlin FHIR library, which is a Kotlin FHIR native library, sorry, multi-platform library on Kotlin. So the main features, the most important thing I think with this library is that we have a very lightweight, fast and lean footprint and very, very minimal dependencies. I will talk a little bit more about that in a minute. It also boasts clean, modern, and elegant Kotlin code with very minimalist class definitions. So I was told that sort of using the word elegant to describe your own code is narcissistic. But in my defense, what I mean here is I think Kotlin, the language itself, is really elegant, and as a result, what we generate is sort of naturally pretty lean, pretty clean code. So you will see that in a second as well. So obviously we want to do code generation. We don't want to handcraft these libraries, these FHIR data model classes in Kotlin, because there's a lot of effort. We want to be future-proof. We want to easily achieve completeness and maintainability in the future when there's new FHIR versions coming up. So in terms of what we support, we have JSON support at the moment, and that's because of the multi-platform serialization libraries support. We don't have XML or Turtle. I mean, to be frank, we have no intention to support those formats either. But there are actually other interesting formats, for example, like protocol buffers that's supported by the Kotlin multi-platform framework, and we could potentially, theoretically, bring those formats to the Kotlin multi-platform FHIR library as well. But that's like for the future. So we support Android, iOS, and web development, and we also support multiple FHIR versions. Right. So in terms of dependencies, this is sort of the first point about how lightweight the library is. We only have two dependencies. One is the datetime library in Kotlin multi-platform, and the other one is the serialization library. So clean, simple, no bloat. Coming to the class design, the elegant code. So first of all, primitive types. Primitive types in FHIR is actually quite tricky because they're not that primitive. They have IDs, they have extensions, and then they also have strange behaviors. For example, if you look at the datetime or the date classes, datetime or the date data types, they can be partial date or datetime. And that is not the primitive behavior in any language at all. And it's very easily, it's very easy to write bad code against that kind of, those type of like primitive data types. So what we've done here is that we have wrapped these data classes in code that we have generated specifically for this library. I'll give you an example. It's very small. I'm very sorry about that, and I can't really zoom in. I'll try to. So basically, on the left, we have created this sealed interface where we wrap different sort of partial dates and datetime in this single FHIR date class, and then on the right, that is further wrapped in a date class that is actually used in the final model that we generate. So this kind of separation of concern allows us to also write pretty easy and elegant code when you're using this library. A little bit more on this for choice data types in FHIR, which is again a very tricky thing to deal with. If you use the Java library, the Happy library, you may have noticed for the choice types, there's typically like a whole list of kind of permutations of the different types. So for multiple birth, for example, you would have multiple birth Boolean, multiple birth integer, etc., etc. But we have again decided to wrap these things in a sealed interface for simplicity and for usability. And the backbone elements are defined as nested in the classes, as you would expect. Just a quick note on the sealed interface point, right? So when you have something like multiple birth, which is a sealed interface, in Kotlin, it works very well with this thing called smart cast. So if you're trying to figure out what data type that is, you put in one statement, and then you can write fairly elegant sort of code to deal with the different data types simply, rather than having to check different data types, with the different sort of property names, and then see if one of them exists or not, right? So this is much easier. So as a result of all the things that I mentioned, we are able to generate classes that pretty much have like a one-to-one correspondence from the data elements in FHIR to the properties in Kotlin. So that's the sort of in your IDE, normally there's a little window where it shows the structure of the class. So that's the screenshot I took for the patient. You can see it's basically a list of properties, and they all just simply map to the FHIR definitions. There's no garbage, no junk for you to worry about, and it's very clean. As I said, it's a code generator. It's a Gradle code gen we wrote. So basically how this works is that the code gen plugin will take the FHIR spec in R4, R4B, and R5 at the moment and read them into memory, and Kotlin Poet, which is a code generation library, will then generate the data classes. And then we can create the JVM target or native targets from that. Right, so a big chunk of how this should work, like why this can work and how this can be used in your application, is really about serialization and deserialization. It's a very important part of this library. And it's not that easy to do because how FHIR JSON itself has a lot of intricacies. I think I mentioned that when you might have the choice of different data types, and that will generate a whole like a list of different JSON properties. But also for primitive types, you also may have the underscored field. I don't know if you can see this. Apart from the birth dates field, you also have an underscored birth date. And that's how FHIR handles elements. So when you have like IDs or extensions, and those things are stored in that field. So it's kind of difficult to map directly from the data model to the JSON. So what we have done here is we introduced a new class which we call surrogate. Well, it's actually a concept from the Kotlin serializations library. But the surrogate acts as an intermediary, right? So it maps to the JSON like perfectly, pretty much one-to-one. And then we do a conversion from the surrogate to the memory model. Because as a developer, you don't want to program against sort of all the different fields in the JSON properties. You want to program against a very clean data model. Right. So to use this library, before I jump into the demo, it's fairly simple. You just include it in your dependency, and then as you would expect, you can sort of import the data classes and create new patients, and then you can do whatever you want with the different sort of fields. I mean, one thing that's really important for us is that I think we really want to have predictability. So it's very easy for developers to write code. And then similarly, you would have serialization and deserialization. Round-trip test is important here. I think the testing we have done is we basically took all the published R4, R4B, and R5 examples. We deserialized them, and then we serialize them again to check that there's high fidelity. So everything that can be expressed in JSON, we can express them in memory and then serialize it back to JSON and have character-to-character fidelity. I'm going to do a really quick demo because I think I might be running out of time very soon. So this is a project. Well, so this is the code itself. You can see there's some patient. This is a patient class. But what I want to show you is that I've got a demo project which I created using the JetBrains multi-platform project wizard. So now in Android Studio, because I have a like multi-platform plugin in the IDE, I've actually created a few different things here, a few configurations here. So I can run an Android app, which you can see is a simple patient list I created using the patient model. So you can have this list, it's basically a list of JSON, which I deserialized, and then I presented them in the screen. You can click through and go back. And then I have an iOS app, which if I get to run, might take a minute, but, oh, there we go. That's quite quick. So you can see in this emulator, I have exactly the same app that I can click through and go back. And then thirdly, I can even create a web app. So if I just restart this web server that's using Wasm.js, I've got this list of patients on the web as well. So you can click and go back. So this is the power, I think, sort of multi-platform development and this library is going to really unleash, right? Just to emphasize, I think this is not, we're not writing a FHIR server. We're not even writing a database. But this is simply just like a data model library. But what I'm hoping is, because now we have this with a clean dependency, and as a clean data model, it's going to enable the community to come together and start building tools on top of this and create a whole ecosystem on multi-platform. I think I have 1 minute left, but I just want to shout out that sort of emphasize that we have some future work to do still. We have just published the sort of 1.0.0-alpha1 version. So please go and check it out, but give us feedback. And then I want to acknowledge the help we have received from Eat Boyar and Ali Kitoto for their contributions. Thank you.
Thank you very much, Jing, right? I know I said it right.
Yeah.
We already got a question over there. Perfect. Don't even have to ask anymore.
So great stuff. I look forward to using it, actually. But I got two questions, one about nullability, even though it's a Kotlin talk, and one about mutability. So nullability first. So if you could please go to the patient model. Yeah. I noticed that maybe in the slides, I think it was pretty easy to see what I mean in there. Or yeah, that works. If you scroll down to, for example, address, because that's a list type. In your classes, you have a nullable list container, and then the type that is in the list is also nullable. Yeah. So you have to deal with the case where there is no list, the case where the list is empty but present, and then the case where the list is existing, not empty, but the only element is null. And then there's the case you're actually interested in where the address is present. And I feel like this is something that you might still have to take a look at because that's just too much of a bother, right?
That's a good point. There is an issue on the repo.
And
this, I think that's a very good point. So when we started writing this, we just made sure everything's nullable because almost nothing in FHIR is sort of compulsory. But these are some of the examples that we have to revisit. Yeah, thank you.
Yeah, so I feel like in this case, the list should always be present when you deserialize it, but it might just be empty because that's how I would think of it when I actually then create like an address type. I don't want to check if a list is existing. Yeah. And then leading into my second question, when you created a patient in your slide deck, used patient parenthesis, so the default constructor, $, yeah, that slide, exactly. So like, that's more of a question of architecture and like programming styles. So you decided on making those mutable classes, right? And I think that kind of tracks with what people are expecting coming from Java, especially like with the Harpy stuff and maybe even .NET. I have not really worked with that, but it's not really a Kotlin thing, right? Like in Kotlin, a lot of people love immutability compared to mutability, and I firmly fall into the camp of immutability. And also, you Google folk also like immutability when you use compose stuff, right?
Yeah, that's right. I think that's a debate that definitely should happen, and then we should continue to talk about it because I don't really know if there's right or right answer. Yeah, very open to feedback. I'm sure if you ask 100 people, you get 3 different answers on this question, at least. Well, okay, that's another one. Yeah. Yeah, maybe. I don't know. Like I think sometimes we have to take hard decisions and just say no to some people because you don't want to create something that becomes increasingly complicated over time and you will suffer death by 1,000 cuts by that point. So. But we should definitely have this discussion. I think those are really good suggestions. Thank you.
Yeah, I like the proactive thinking and these tough questions. Maybe you have one more here. Yes.
I have a question regarding this surrogates. Do they get optimized away by the compiler, or are you basically, or is it like copying everything twice, once into the surrogates and then into the JSON?
So that's just a way. That's just a way to do serialization. So essentially, we copy we create the surrogate, which is what the serialization library uses to serialize and deserialize, and then we just do a conversion back to the model. So I think I don't think the compiler does any. Well, I'm not aware of any special trick that they would do for this. But I think maybe the interesting question is, what does it mean for performance, right? Because you really could write a completely custom serializer that deals with everything more natively, I guess, without having to create this intermediary sort of data model. And I agree with that. I think more testing probably should be done to figure out what we should do there. But good point, yeah.
Thank you very much. Do we maybe have another question from the audience? Well, if not, then another round of applause for Jing.
Thank you.
And see you at the next session. Thank you.